Okay, welcome everybody. I'm playing with some of the new features today. So there's this thing called Showcase. I don't know if can you guys use it? Apparently, there's some way to post links out of Hangout into the Google Plus forum. Except then the one thing I tried to post was the link to the meeting today, and then it didn't work. It said that there was an error. But anyway, see if you can anybody else use it or see it? The Showcase. It's a little set of yellow tags, like little yellow price tags on the.
I clicked on the button and I see something open on the.
It says no featured items
yet. I see something, yeah.
Yeah, I see it there.
I think it's not quite working very well. And then there's the QA one for folks to ask us questions. But okay. Anyway, let's get started. All right, so just a couple updates from last time. So it's been a little while. We skipped the last meeting, so probably a lot of updates for folks. Except from me, since we met last time, although it seems like a long time ago actually, we haven't had a meeting since. We did this journal club. A couple folks here joined us on how does the worm crawl, and if you didn't get a chance to check it out, it is on our YouTube page and linked in the agenda. So check it out. I think it's one of the more important ones that we've done in terms of pushing our science forward here in the project. And I think that so it was very helpful to get Netta Cohen in and Tom Sanders as well to talk about their views on what we understand about the locomotion of the worm crawling, what is still needed to understand. I think it's just a nice little sort of like 1 hour summary of sort of the state of the understanding of the neurobiology. And so check that out if you didn't get a chance. There's a new journal club coming up this Friday with Rick Gherkin, who will be talking about SciUnit. I will be putting out the invites for that on the Google Plus channel and posting on social media, so have a look for that. Are there any volunteers in here for being in the panel for that on Friday? It's about this, I believe it's this same time. Let me just confirm that. Yeah, it starts exactly at this time, but in 48 hours from now. Folks going to be available? Anybody here maybe available? SciUnit? No?
I don't think I will be able this Friday, although I will try. I will let you know like a bit in advance.
Okay. Well, I will rustle up some other folks.
I can. Sorry, I can do that.
Okay. Michael and Tom both. Okay. Awesome. Thanks, guys. Cool. So I'll add you to the invites for that when I put that out. That should be interesting. Probably relevant. Yeah, pretty relevant to the movement validation stuff. So that's good. And then Tom, yeah, and then there might be some applicability as well for the other pieces. Basically, it's a framework for better management of information, and we'll get the details about it on Friday. He's been looking forward to talking about that for quite a while, so that'll be good. Okay, so there's a couple updates. So when it comes to Release 7, guys, so I've just sort of cleared out the dates on the milestones that we've had there. And so my observation, I think, with the last set of milestones is that I think we kind of need to, rather than thinking about milestones, I think we need to think about sync points between the different projects, the way that they've been going. And because I think that folks are chugging along and we're making a lot of progress in a lot of sub-areas across the project. But my observation, I think, is that we need to create the space for crossovers. And so rather than just sort of have this big laundry list of sort of all the general milestones every time, I thought maybe I'd try something different for this next 6 months and just focus on sort of one burning issue each time and kind of create a little bit of a space, maybe 5 to 10 minutes of discussion amongst the group to see kind of what we think about where we are with this, hopefully here. And then potentially use that as a launching off point for some other, either offline interactions or maybe some other hangouts, something like that to kind of pull this effort together. Because There's a lot of good stuff happening. So the one I wanted to focus on to start off with is making it as a GitHub issue is probably a good way to go, is issue number 177. Okay. So this is one here. I'm going to try to use this link thing on the showcase. Let's see if it works at all. Okay. Hey, that actually worked. So issue 177, okay, is augment cybernetic to receive muscle activations from some neuronal model. Now, I put this together myself as sort of a cross-cutting issue. As volunteers have come into the project and sort of I have some conversations with them, every now and then folks say, oh yeah, well I'm pretty good at Python and C++ both, and what can I do to help? And I sort of have pointed some folks at this project over time. Nonetheless, since we've had this issue up in March 5th, there's been some little progress that's been happening, sort of nibbling around the edges. But I think as a whole, we haven't really confronted this one. And so I kind of wanted to take a minute just to explain kind of what the importance of this is. So back in December, we made a lot of noise, or a lot of noise got made. I guess weren't really the ones driving it, but a lot of noise got made about the progress with the cybernetic body model. And this was it was a really huge milestone for us in that the Novosibirsk team. Plus Mike Villa really worked together to get the SPH model working such that it could do wiggling, and it was something that we've been waiting for a long time. And not only that, there was a Python layer created that could inject activation patterns into the muscles that were there in the C++ code base. At the same time, we made a lot of progress in getting activations of neurons and motor neurons, or all kinds of neurons, into Python via the work of Porritt Gleason in the C302 layer. And so for the last 6 months, it's sort of been an open question as to, well, what is our strategy for putting these two things together? So on the one hand, we have a very simplistic sinusoidal input that's going into making the crawling happen. And on the other side, we have a neuronal model that isn't putting its output into anything. So there's been efforts on smaller parts of this to work on getting even more detailed models of the synapses between the motor neurons and even more detailed models of the muscle activation in the muscle model repo, and that's ongoing. And that's work Rainer's been doing, and Mike started, and other folks have been working on. But it's still, I think, a hard problem, or for some reason, for folks to get in this intersection. And I sent a mail on the list on last week or so, Wednesday or Thursday, of somebody who had tried. Basically, they built the cybernetic code base, but it was running slowly on their MacBook Air, probably because they didn't have a GPU, basically. But the upshot was that they were going to have trouble sort of helping work with this task because of sort of performance issues. So anyway. So what this issue talks about is basically what I just said, and it proposes some prerequisites of what you need to do. You need to build cybernetic, you need to download and install C302, you need to understand how sinusoidal input makes into cybernetic, you need to try changing the sinusoidal input directly, observing if you can make a difference from running cybernetic, try making a change, the execution of C302, and see if anything changes, identify how to pull the numbers into the C302 graph into a Python variable, and then try to make a connection between those two. Initially, starting off with a proposal that, well, if we can't, maybe it's a little ambitious to get sort of a real-time loop going, so let's just see if we can put anything that we get out of C302 into the cybernetic input. So I just kind of want to open this up for discussion. Maybe this issue is not that important. Maybe this is the wrong way to go about it. Maybe this is the wrong time to approach it. Maybe this is the right issue, but we haven't really, gotten focused on it. Like, I don't know. It seems to me that there should be some progress here, but I want to maybe, have like 5-10 minutes of discussion, have folks offer their opinions or perspectives. What do you think? Is this what we should be doing? If it is, what could we do to make progress on it? If not, what should we be doing instead when it relates to the nervous system and the body model?
Uh, I think I think it's a good issue. I think that uh, we don't need to bridge the two things, and to at least at the place where the neuronal model can be improved. Okay, and these improvements could link back into cybernetic. I don't think real time is going to be feasible with the current level of technology, because it's like with real time, you need to start putting in place a sort of an infrastructure which goes beyond probably the Python scripting. Like you start doing this to get there, to have basically the different simulators that run at different time steps, synchronized, etc., etc. Not that it is not technically possible, but maybe that wouldn't be the right tool. But having a way to connect activity that is simulated from the neural model into cybernetic, I think that that is a good thing. Now, one of the challenges is going to be how to do it, as in like cybernetic, the current code base, okay, basically the model that gets simulated is a bit um, coupled with the code that's simulated, okay, and either it's like we kind of need to identify how we want to go about this, because either you hard code everything because you just want for these signals to go there, and that might be a way to go if code engineering is not a priority. Obviously, maintainability is not going to be great either. But say I'm thinking about these cybernetic model with all the muscle cells. So having these signals for the muscle cells, which are input signals. Okay, so at the very least, you need to have something like that. And there was something about input to the muscle cell that Mike was using in that script. But it's like it was kind of becoming a war-centric code base. So my question and it's more for the people working on cybernetic, would be, we're calling this code base cybernetic, but is cybernetic, does cybernetic want to be something generic, or does cybernetic want to be something worm specific? Because if it's something worm specific, then it can be done. If it wants to be something more generic, there is more work that needs to happen on cybernetic before having such a functionality working in a generic way, and a lot of this work would be similar to the kind of work that happened when porting cybernetic to the Python. So that's something that I think should be resolved, at least like discussed.
Okay, Sergey, you're just joining us. We're talking about issue 177 and connecting the output of C302 into the cybernetic body model, and if that's what we should be doing and how. And so this is probably pretty relevant to you as one of the only cybernetic authors here. And so I'm asking the question if cybernetic should be considered to be generic, or if it should be considered to be worm specific, if I captured that correctly. Do you have any thoughts on this?
Yeah. Some times ago, we with Andrei discussed this and decided to divide cybernetic into dependent parts. One of it, it's part in which we working with warm body simulation, and one of parts it's part in which we working with improvements of performance and so on and so forth. This is step 2, like Matteo said, generic way. So For now, I think that warm body simulation it's not a big part of code of cybernetic which can influence on another part in any way, in any case. I can say that cybernetic it's universal tools for modeling everything which you want. You can create a scene for modeling, for example, I don't know, like liquid scene, elastic scene, without any simulation, any biological things. So.
Okay, Matteo, does that sort of answer your question?
Yes, yes, to some extent. Basically, what Sergey just said is basically that cybernetic wants to be generic. Now, in order for cybernetic to be generic, then a format needs to exist in order to describe what the model is, and a format needs to exist to describe, bringing this one step further, focusing on the issue that we are discussing. This format needs also to discuss things like think of the muscle cells, okay? If you're thinking about there is something that contracts a muscle cell, what is that? Is that something that you can apply if you're modeling with cybernetics? If you're modeling something which is, for instance, liquid or not, then you have to define something like a schema. You need to do a sort of domain analysis. Okay, what are the things that you can describe with cybernetic if you want to make it generic? And then liquid is one part, elastic is another part, membrane is another part, and then you start looking at variables that can make elastic matter contract, and how do you specify that, blah, blah, blah. And then you would have to describe the world model using such a format that you define, and then you would have to bridge that with the neuronal model. And this is, I think, from a software perspective, the right way of doing it. But it is time-consuming, and it is a little bit like all the things that happened on the Geppetto side of things. Because we defined that schema, we removed such a schema, we removed all the model bits from the code itself, etc., etc. So all I want to say is that if
in the last version of Sergey, correct me if I'm wrong, but this is kind of happening as well, because one of the last posts of Sergey on the discuss list, Sergey was saying that they have removed the model generation from the code, and now the scene is being loaded. And so I think some of this stuff is underway. There is a loosely defined format. I agree with what Matteo is saying, but I would also say that some of this stuff is already happening. That's my impression, at least. And based on Sergey, these discussions with Sergey on the mailing list, and also I think my view is that cybernetic needs to define an API and this script that makes stuff contract and things like that. That can be accessed to the, basically that can talk to the API, and it doesn't need to be cybernetic. So this is just a kind of a middleware script that can link any neuronal simulation or anything that instructs contraction to the cybernetic API, and that way it's also a way to keep cybernetic just as the engine with an API on top of it, and the API can be C++ or whatever. I'd just be worried of building too much stuff into cybernetic other than exposing an API. But I think it's going in the right direction, because for example, now in the development branch, the worm is not there anymore. are coded in the stuff. There's a you can load a scene, and this is recent news. Correct me if I'm wrong, Sergey.
No, you're right. Also, I think that crucial thing in this that some tools which can create a scene for both of in both format for JPEG and for cybernetic, and this tools is configuration generator, and unfortunately it's not so simple to do such things, and take into account in this all small specific things for simulation.
Okay, I want to hear from. So thank you guys. So I want to hear. Is there any other folks want to offer perspectives or opinions other than Matteo, Giovanni, Sergey on this? Obviously, kind of looking from the outside of this code base. Other folks maybe less involved.
Well, I agree that we need a. It sounds perfectly reasonable that we need an API to drive cybernetic, which also implies, I think we had this discussion way back with Tim about sort of feedback from cybernetic to whatever's driving it, so it doesn't, it knows when to do the next thing or something like that, But from my perspective also, like, I don't know enough about the output of C302, which I hope to find out soon more about. If it's just like neuron sorts of outputs, which are very easy to use. I think Johanna's had some answers to that maybe. How do we get, if I'm correct, and it's just neuron producing the outputs, we've got some work to do to get that captured so that it can be put into the API of cybernetic and drive it. So that's just my 2 cents on that.
Okay. Cool. Other folks who haven't spoken yet?
Yeah, maybe just on what Tom just said, with the output of Neuron. I mean, I'm actually right now working, or have been the past week, working on having the output of Neuron, or basically any Neuron script if it's finished, recorded to Geppetto recording, which is on HDF5. So I mean, I don't know if we can use that for or if we can anyhow interface that to stuff in cybernetic, but it may just be an easy way to record things from C303.
Okay, yeah. So that's just interesting. So it receives output from Neuron. I think, and we would need to have Foreg here, but I think that the key thing for C302 is to get output out of like JNeurML, right? Which kind of has its own solver in it somewhere.
Yeah, but you can also with the JNeurML, you can also interface it to Neuron. So basically, you have the NeurML stuff, and then you can transform it to a Neuron script or to a Neuron model.
Right. Okay, very good. All right, guys. So then, so what I'm sort of hearing from folks is that maybe this particular task is not doable right now, and that we should kind of backlog it until. So the suggestions so far sound like they are, number one, refactor cybernetic so that it's more generic, which is somewhat in progress, but that's kind of a prerequisite to doing any of this. And then the other thing is to make an API. Now this is what the Python script looks like, by the way, that actually does run code, and it's not an API for sure, but I mean it does have an ability to basically send in activation patterns in a series of arrays that will then, set the time course of the experiment of the muscles. But I think the second thing is that basically this is also not doable until we have that API put in place. So
yeah, pretty much. I'm sure that if Mike was here, who wrote this, he would tell you that what you're proposing is doable right now, because
Okay.
the problem with that script is that it assumes the configuration, it assumes how many muscle cells are there, it assumes a bunch of stuff, and maybe it's okay to assume that if we just want to do it. So I think that's a trade-off decision that we need to make. Is it something that we are okay with, or we want to put some more work into it so that we can be more free to experiment slightly in the future? I think like if you extend that script, link it to Neuron running C302, and assume that you know how many neurons and where they are, that stuff could be done. And I'm sure Mike will tell you that you wrote that in relatively short time. I think there's a trade-off decision to be made. We seem to be leaning towards let's do it right, but that wouldn't. I just would want to say that doing it with the script the way that it is now, it's not wrong. It's just it depends what the goal is.
Yeah, if I can say something, I mean, what Joe is saying, what Joe is saying is basically going back to the question that I was asking earlier. Okay, so we have what Mike did back then, which was just generating a sinusoid signal and sending it to the muscle in a hard-coded way, could be changed in like not 6 months. It could be changed in a couple of days to instead running through Python C302, and instead of sending those signals that are randomly generated, sending signals that are coming out of C302. This could happen in a week, okay? And what this would give us is a scientific tool which is able to connect the neuronal model to the worm body. Making cybernetic generic is something that can certainly be done, but it is a lot of work. And I want to say that, in a way, it's the kind of work that happened when porting cybernetic to Geppetto. There is a module in Geppetto which is a cybernetic module, which has exactly the same kernel, and that took a lot of time to be built. Now, Geppetto doesn't have yet the ability to control from the outside what is being simulated by that cybernetic module or by any other module. It's a long process. We're doing a lot of engineering work, and I remind anyone that there is a Geppetto meeting going on every 2 weeks. But one thing that we always said was that cybernetic and Python, etc., the goal was doing science explorations, something that you need to do quick, something that you kind of don't care if the thing is hacked together, you don't kind of care if if you're assuming that muscles are there, etc., etc. But if we start pivoting towards making the cybernetic code base a properly engineered tool, then that task that could be done next week will have to wait maybe another year. So as OpenWorm, what is that we're interested in?
Yeah, it's a good question. I mean, how long do we want to wait before we have some kind of connection between a nervous system and a body model? Maybe we're okay waiting a year until that loop is closed. Do folks want to comment on that?
I think it's important to do that. You know, it'd be a big step for us. So.
Yeah. Other folks?
I think one doesn't exclude the other. Like, if we just go and do it with the extended mic script, it doesn't mean that we cannot do an API still, right? So I think there is space for doing both. And as Matteo was saying, that script, if somebody's working on it, to modify it and have as input the output of the C302 stuff. What's missing? It's pretty much rework that script so that the output comes from the neuronal simulation. The rest is kind of already there, and that was Mike's plan, and I'm sure he would have done that if he wasn't writing his PhD thesis. So that was his plan. It was like, that's a proof of concept. It's a script that glues together activations to the engine, and the next step was hook up the neurons. But I never got to do that because then it got sidetracked, and of course he's got an important thing to do with his PhD thesis, and also he's getting married, so that takes time, as you know. But yeah, I'm sure he would have done that, but it's still very doable, and the script is there for anybody who wants to do that. I think it would be nice to invest a couple of weeks on that, or even a couple of months on that. And that doesn't mean that the rest is not happening, but it would decouple the two, and at the same time, once we have that, basically once we extend Geppetto to force variables and control the SPH stuff from the outside, then we can do the same in Geppetto. But this can be already done, but in cybernetic, as demonstrated by that one script that Mike wrote. So all this stuff that we are saying, oh yes, let's do the API, let's do that. That's everybody wants to see that, but at the same time, it doesn't exclude that somebody can work the script and link C302 to the muscles.
Yeah, just to elaborate, I mean, our goal is to produce an integrated artificial worm. So, also, we kind of have we want to kind of steer away from these silo projects and do as much as possible as early as possible when we can to make them work together. So, I mean, we have cybernetic, we have Geppetto, we have C302, we have the stuff that I'm working on. So at some point they all got to come together. Maybe it's better a little earlier than later, because later people kind of get into a sort of state where it's hard to do massive changings to interface these things, So anyway, so just let the worm kind of be our guide as far as moving towards the integrated worm, I think.
All right, good. Well, I know that Michael here has to leave in 5 minutes, so I'm gonna I think table the discussion for now. I'm gonna seek to have another session on this topic and this question. So folks who have interest in talking about this further, please join me for that. I'll probably put a poll out or something for folks to see what we can do to focus on this question one way or the other. Because really, it's like there's, I think we all have our own individual senses of what our priorities are for different pieces across the project. But in this period of kind of coming back together and looking across the project, this one stands out as something that's like a burning topic that we should collectively decide our priority on it. So I'll keep this topic going here separately. So let's give Michael a chance to give his update. So let's turn over to going through folks' updates. So Michael, please.
Yeah, I mean, I certainly don't mind waiting. That was a very interesting discussion, probably a very important one to have. So yeah, I can just jump in and give a little update on the movement validation effort. So it might be useful for people to click through to this PDF here, which is in the documentation folder of our repository. So this is a flow chart that I created to sort of get a better grasp on where everyone's efforts are going on the movement validation, because there are a few parts of the pipeline that people are working on at the same time. So this is, if everyone's got the chart up there, basically each row is a repository, and the one that's being actively worked on is the third one there, which is the movement validation repository. And we're basically moving from, the progress has been to try to port from the SegWorm repository to SegWorm MATLAB classes, which is Jim's version of the Schaefer Lab authored SegWorm repository, and then onto the Python movement validation repository. And so that's of course been ongoing for maybe close to a year now, and we've certainly ported some of the pipeline. So there's about 8 steps in this pipeline, going from the experiment to the raw video to the contour obtained from the machine vision algorithm to the features, and then onto the statistics. And I sort of show that in the blue section there, the calculation pipeline. So you can see that let's just focus on something here. So on the video side, we're working towards getting a copy of all the videos that the Schaefer Lab has, and hopefully within a couple of months we'll have that in the form of an external hard drive that we'll host in some form, and Stephen's working on that. As for the contour code, which is the machine vision algorithm that transforms the raw video of the worm to a contour that can be worked with statistically, that algorithm we hadn't done anything with, really. That was something that the Schaefer Lab had, and we hadn't touched that. But now we have a new recruit. His name is Aaron Lang, and he's from Australia, and so he's hopefully going to work on that and port that over so that we'll have that within the Python repository there. Then on from the contour, the rest of the pipeline continues to take that contour and calculate what we call sort of pre-features, which is normalizing the contour into 49 points and getting it ready for the feature calculation. And we have another person who's a new person, Miguel Camarena, and he's from Mexico, and he expressed some interest in working on the project, and so we thought that would be a good step for him to be working on. So he's working on that. And then on beyond that, we have the features calculation step, and the good news is that we've about a month ago we finished translating that, and beyond that we have the statistics, and I'm working on translating that as we speak. And then ultimately, of course, we have the fitness function that we hope to provide that feedback loop, that we hope will provide a feedback loop for the simulated worm, and tell us if we're doing a good job or not with the simulation. So that's sort of the big picture of our progress in translating this pipeline and making it work for the OpenWorm project. And that's basically my update.
Awesome. So you've been fielding some meetings with some folks coming in as well, right?
That's right. Yeah.
Yeah. It's been really great as well. Thank you from my part, because a lot of folks sort of originally filtered through me. So very cool. Alrighty, great update. Shall we go on to Tom?
Okay. Well, I've been pursuing the getting a neuron, not C302 yet, but just a neuron implementation of a training fitness function for the genetic algorithm. And I've been using the pharyngeal set of neurons as a subject to train them, and on a very small scale I've got some promising results. So basically trying to train the pharyngeal set of neurons to do a certain outputs given certain inputs. And that seems so far so good. I think just yesterday I put the thing on the, ported it over to the supercomputer that I've had time on, and it ran 4 generations and stopped. I think the output file neuron produced like massive amounts of data from 250 of these things running simultaneously. So I've got to actually stem that off. I had some problems getting Neuron compiled actually on the supercomputer, which I managed to do yesterday. So very short term, next step is to try and actually do that pharyngeal neuron training on the supercomputer, and then looking forward a little bit, Stephen and I are going to have a meeting with Brian Mitchell and hopefully Parik at some point to get the C302 stuff integrated with the training and work on that. And I think that's good enough for now as far as what we're going to do. So that's my report.
Yeah, no, that's good. And I think it's quite a big push so far already, just to get the pharyngeal neurons are working and coming out through neuron. And yeah, I know that building C++ code on new architectures can be challenging. So awesome. All right. They're coming in through through GitHub as well. I guess another point to make is that the BioNet repository is now hosted under the OpenWorm organization. So thank you, Tom, for that as well. And it's also helpful because I am now by default following all those repos, and so now when commits go in, I sort of see stuff pop up like on my phone. So awesome. Okay, great. Let's go to Matteo.
Okay. So I've been working on releasing the 0.1.6 version of Geppetto. So we had a meeting on Monday. So I always try not to get into the same level of details here. But this was sort of an important release for Geppetto because there were many refactorings that were kind of merged into the master branch and that are part of the release. So one thing that happened is that now there is an object model defined both server side and client side in order to describe basically the Geppetto simulation and basically going from the top level nodes, which are the entities which this kind of we want to simulate, like for instance the worm or going down the hierarchy, a muscle cell, a neuron, etc. Up till defining also an object model which can describe what are the models that are actually being simulated. Because one thing that you've noticed so far is that like you load an example of Geppetto, like for instance you look at the first one with the simulation of a neuron, you do not actually see anything which tells you what is the model being simulated. And this is because there was work needed, and there is still work needed in order to do that. But the kind of work that we're doing now is to get there. So to basically have a look, for instance, if we're loading a NeurML model, to have a look also in what are the dynamics for the neuron that are specified, what are the parameters, so that you would not only see how that's simulated, but also what is that getting simulated. So that is something that that progressed now, and now we do have an API client side which allows to access these different objects. Now there will be in the forthcoming weeks basically work that we will do with different people, basically try and create and populate this model from a NeurML. To populate this model from a NeurML for a NeurML model, and and also from SPH. So that's something that now will happen. In terms of other news, other things that happened, we had a refactoring of the UI so that all the components that are in the user interface of Geppetto are actually separated. So there's not anymore something like an index file where everything is defined, but there is rather a composition of different components that are plugged in together. So it's something dynamical. And something else that happened is like there was Matt was also working on this, the updating to Bootstrap 3, which is the latest library, and that also required some work, and it kind of makes the whole UI more responsive. And another thing that I worked on is adding support to visualize OBJ models, and I will try now to do screen sharing. Bandwidth ain't up to the task, okay? But I just wanted to quickly show what I was bringing up in the meanwhile. I wanted to quickly show what I was talking about. So, for instance, this simulation, which is the Ashkenazi cell simulation. Now there is an object which has an API for it. So this is the object for this cell, and it is possible to do things like obviously the API can be expanded, but it is possible to control what is visualized, for instance. So you can hide and show the API. You can see and get what aspects are defined for that specific entity. In this case, it's telling us that there is an electrical aspect, which is basically what the aspect that we're simulating here. And like if you do things like hhcell.electrical, then you can see we're still working on improving the output to the console. But for instance, you can see that this aspect is being simulated by JLAMs. So once again, information that is now becoming available. And the same thing is there if you load up C302. If you go up for instance, to V, okay, you will see that the type of this is a variable node. So this is the meta model that I was describing. And so that through the API, you can do things like get value, so that you are able to just, using the console, getting right to the variable that you're interested in, that is a variable that you're watching, and then, for instance, you can get the value. And this is the value that the simulation has at this particular moment where I pose it. So there's more work that needs to be done here, all right, in order to take all this information and put it into a widget so that it's possible to explore the simulation through a tree visualizer, for instance, and there's folks also working on that. And so on here, I was trying to load but I will do this because this model is rather big, so it will take a while. I will do it offline, not offline, but I will give the word basically, and when it comes up, I will show you guys. And it is basically it's nice because the model comes from iWire, which is a project at MIT, and you surely have heard of the game, and it's basically something along the lines of Folded, but it's a science video game to basically reconstruct morphologies, and we're able to visualize their morphologies now on the beta. And as it comes up, I will explain again. But that is pretty much everything, I think.
All right, just that? That's a lot.
Yeah. Well, I'm reporting basically all the work that happened on Geppetto, so it's not just stuff that I did. Obviously, it's like
of course,
stuff that everyone can do.
No, awesome stuff. So that platform's definitely making a lot of progress. Great. All right, Giovanni. Let's do.
Hello. So there's two sides to my update. One is about Kickstarter stuff. So as you know, we run a successful Kickstarter campaign, and the fact that it was successful means we have to fulfill a bunch of rewards. The main reward is the worm sim, and work started on that. But the update that I wanted to give now is about physical rewards, such as posters and T-shirts and stickers. All that stuff has been sent last week. It was sent in waves, so I'm sure if some of us were backers of the project, you guys should start receiving stuff if you haven't received it yet. So there's people posting pictures on Twitter and social media with T-shirts and stuff. So that's taken care of. Hopefully it's cool stuff. And then this is in terms of Kickstarter. In terms of development, I worked on some Geppetto stuff. Some of the stuff Matteo was talking about, in particular, design for installing new widgets, client-side functionality to pretty much add a widget on the fly. And this is just not for widgets, but it's the foundation for adding components, client-side components that will lead to the customization of the front end. And the reason for doing that is that, for example, we want to use Geppetto as the platform that we develop the worm sim on. And for example, you can imagine instead of being a Geppetto logo, there was a worm sim logo, stuff like that. Not just that, but that's an immediate example. And then also started working on worm sim use cases. There's the document is being worked on at the moment, and Stephen is also working on that. Matteo is also working on that. Matt is also working on that. So I think we should share that document with everybody if it's not already. And I'll probably post it somewhere on the discuss list, something like that, soon. But yeah, that's pretty much what I've been up to.
All right, great stuff. I guess probably also under Kickstarter stuff, although you're not directly driving it, we can say that we've also started the OpenWorm Academy since the last time around. So I've actually been driving that. That's a reward, of course, for just certain backers. So why you're probably not seeing it popping up into the public. But we've had 2 lectures already, and for the folks that are sort of at the Worm Professor tier, I guess, and folks at the Worm Legend tier will be receiving the recorded videos from that and the materials starting probably next week, I'd say, and a bit of a time lag, so give us time to edit up that content. But both of those have been moving along as well under the Kickstarter, and I think there's also an effort to get out the names of backers and stuff, I think, on the site too.
Oh yeah, I forgot. It's already there, actually.
You want to share that?
Yeah. It took a while, actually, but it just probably wasn't the most exciting activity, so I forgot. but it's important. So I'm just sharing my screen. Basically, editing a bunch of HTML there. So on the supporters page, on the supporters page now, there's a section called backers, and there's a bunch of all the people who have backed the Kickstarters are now there, acknowledged. So this is pretty much credits on the website that we promised, and these names are also going to go on the WormSim source code when we have the bundles for the WormSim. So yes, thanks for reminding me of that.
Yeah, no problem. So it's really cool getting folks recognized for the Kickstarter. So that's coming right along.
Definitely.
Very cool. All right, let's go to Johannes, who I believe is in his last week of Google Summer Code, if I'm not mistaken.
Yeah, no, that's totally right. So on Monday is the official end. Yeah, I've made quite some things in the recording repository. So here is the link to that. It's still in the development branch, everything. But I'll merge it soon to master. And yeah, so basically what I've done is interfacing the recording things for Geppetto to Neuron and Brian. So the idea behind that was that, as you know, currently in Geppetto we can run neural simulations, but a lot of the simulations and models that are published are in other languages, for example, for Neuron or for Brian. And the idea there was to have something where we can write data from Neuron or from Brian to a Geppetto recording, and that recording can then be replayed in Geppetto, which just means that the simulation is running like usual, but the data is not calculated, but coming from a recording. And yeah, so I can actually show you something. I'll do screen share. Cool. Yeah, so the thing that I'm showing now is what I've developed most recently. That is that you can just give a model file from Neuron or from Brian, and the algorithm executes that model file using Neuron or Brian, and records all the variables and all the values during that simulation run, and actually saves it to a recording, which is pretty cool because you do not have to do anything more or less. You just give the model file, and it spits you out the recording, and you can in the future or in the near future replay that in Geppetto. If you look in the recording repository, there's a folder called scripts. There's also some documentation. Well, I've created yesterday a pretty easy script, which is called record, which is a very simple entry point into this without using a lot of code. And yeah, so here I have this cobra.hh. That's a model for Brian. So it's taken from a publication. Yeah, so this is that cobra.hh file on the right here. So you can see here's everything where the parameters and the neurons and so on are set up. And down here, actually the simulation is run. So yeah, it's just a pretty normal file for a Brian simulation. And if you have that, or you can use pretty much any other Brian model, then you can just use that record.py script and from the command line and do record minus Brian, and then give the name of the model file. And yeah, now it will open up that model and execute it. That takes a while. Here it adds everything that's just from the model. Yeah, and now it has finished it and recorded all values from the simulation and wrote them to the recording file here, which is an HF5 file. And we have a look at that. Then you can see that well, here's the neuron group, this P, and for every neuron it has recorded pretty much all variables that this neuron has. So this is one value per time point, and yeah, also so all variables, also the units of these variables and everything, and down here also the time during the simulation run. And yeah, so that is that thing. So now so with that you can again record, just have a Brian or a neural model and run that simulation and get the data to your Geppetto recording, and yeah, in the near future you will be able to replay that in Geppetto. Yeah, so just the status of that, Brian is already finished, so it should be able to work with every Brian script. Neuron is still not really finished. I'll have to see how far I got that till the end of the summer code. But so if it's not completely finished, then I'll also work on this for you. Yeah, so Neuron is it does record things, but it doesn't work with every model yet. Yeah, so if anyone of you wants to have a look at that, I would really recommend this record script here. So it's in the it's just here in the, so that's the recording repository. There's also some things here, some documentation. I will also add documentation to docs.geppetto.org, and yeah, here in the script side, there's the script. And so yeah, all this what I've just shown is also accessible from the Python code. So that's described down here. So you can also go into Python and make such a recording creator, and there you obviously have some more control over it. You can also do what the script does, take a neuron or Brian model and record everything. You can also add any values that you want manually. And one further thing that I've developed before is you can also take recordings that you've actually done from neuron or from Brian, so text or binary files that you've written with neuron or Brian, and there are methods that take these recordings, read the contents, and add all the data to the Geppetto recording. So yeah, that's a way to have a little bit more control over everything, and yeah, you can from neuron or from Brian directly select which things you want to record, and then later add them to the Geppetto recording.
Brilliant. That's awesome. HCF5 coming out of these simulators is really helpful. That's really cool. When it's finished, we definitely need to put it out on some social media, because I've got a feeling that, you know, and really you should probably be the leader of that, but I've got a feeling that like the Neuron and Brian communities are going to be very interested in this, and you're probably already talking with them, but yeah, I mean, have you let folks know outside of this group that you're doing this?
Yeah, we had some discussion on the NeurML mailing list, So Matteo forwarded the one mail I wrote to the OpenWorm mailing list to the NeurumL mailing list, and there's quite some discussion going on with different people also about about recording file formats and everything. So I'll definitely try to get that out to the people.
Cool. So then, in theory, at some point, we were sort of talking about maybe then adding like a cybernetic recording format or something, or how are we thinking about that part? Maybe, Matteo, do you have kind of the bigger picture on that?
Yeah, basically the class called that Jonas was just showing, the module called the recording creator. So it's going to be a matter of either taking a cyber recording in terms of, like Sergey at the moment does dumps in terms of in just a text file, okay? So where you have just comma, I think there are spaces, separated values, kind of thing, and you just have dumped all the positions of all the particles. So it's going to be either a matter of post-processing that into an HTML5 file, imposing the structures of all the particles, or the other way would be to, if you want to do it as also Johannes is doing it, as you're kind of in real time, as you are running the simulation, then you would need to basically control the simulation from Python, which is something that was already done by Mike in that script, I believe, and then just fetching values on the fly. But the bottom line is that the recording will be in the same format, and therefore we'll be able to, in the same way, replay it through Jupyter. And I will be working on the next stage now, on just trying to bridge in what Johannes did with Jupyter. Like I did work already in the past, and it was ready to go, but like with all the refactorings that happened since then in Jupyter, I will probably have to devote some time to fix it. But I hope that by the next general meeting, OpenWorm general meeting, I will be showing some of these recordings that Jonas was showing us inside the HTML5 viewer as spiking signals inside Jupyter.
Awesome. All right. Very good.
Just one note to Matteo about what you've just said about post-processing the text recordings from cybernetting. If you want to do that approach, I think it might not be that much of an issue because I haven't looked at the files, but as you said, they seem to be pretty much like the stuff that neuron recordings actually, what neuron recordings actually look like, and it might be a matter of just taking the code that reads the neuron recordings and applying it to that.
Ooh, awesome. And Mark Watts, the other Google Summer of Code student, is also wrapping up. Sorry he couldn't make it today, but he will probably be posting to the Discuss list his summary and where things have gotten by the time this all wraps up. So look out for that. He has made good progress. We've been following along. Actually, we'll chat with him later today. But that stuff is also pretty exciting, so stay tuned. Okay, so last but not least, Sergey, welcome. How are you? You are in the correct garb. I see your shirt. So what's going on, man?
Okay, I'm trying to work with two projects. I'm finished with cybernetic first release for paper, which we need. I'm not announced it yet, but I want to do this maybe tomorrow.
That's
I
awesome.
prepared code for both version with Worm and without Worm. Who wants to work only with source code and so on. Also, I'm working on Geppetto stuff. There are a lot of problems which I need to resolve. So that's all for me.
You wanted to say briefly what a couple of those things are under the Geppetto stuff?
Yeah, sure. I finished with membrane porting from Cybernetic to Geppetto, and I can say that Geppetto now have last updates code which we have in Cybernetic. Maybe a little changes between them, but it's not big. Also, I'm working with Martin, who trying to create shell body reconstruction from a model which we have in Cybernetic, which generated automatically. He wants to translate this in some mesh-like structure, and I prepared for him data which he needs to do so. So that's all.
Cool, awesome. Yeah.
There's another thing that Sergey has done, and I forgot to mention, which was creating the worm model in Geppetto, in the Geppetto format.
Yes.
And that we still have to test, but it's great that now we do have a one Geppetto file, which is the worm. So we're close to attempt at the very least loading it and see if anything explodes.
Don't hold out. That's very exciting. We're all eager to see that. That would be very cool as well. Groovy. All right, guys. Does anybody have anything else then for the good of the order before we break for today? I know people are out on holidays. I know Balash is on holidays. I think Orig is on holidays, so we didn't have quite as many folks here as usual. Anything else? Alrighty. Thanks very much, everybody. Great progress here this last month. We will get together again in the next 2 weeks. Bye now.
Thank you. Bye-bye.
Bye.
Bye-bye.
Bye.